Hey everyone, this is my second video on section 12.5. We're going to be talking more about lines and planes. We've already talked about parameterizing lines, and now we're going to talk about parameterizing planes and how you can get a line that's perpendicular to a plane, that kind of stuff. So the picture I have here is a plane, and the equation for a plane is ax plus by plus cz equals d, where a, b, c, and d are just going to be numbers. They're going to be real numbers. Okay, so that's the equation for a plane, and this little red vector here is perpendicular to the plane, and it's actually called a normal vector. Normal means perpendicular. Okay, so it's at a 90-degree angle to the plane, and the normal vector n is given by n equals ai plus bj plus ck. So notice we actually have the a from the x goes right there, the b from the y goes right there, and the c from the z goes right there. So that means your normal vector actually has exactly the same numbers as these letters here, capital A, capital B, and capital C, for your plane. Alright? So I wanted to do an example of using this. Once you know this stuff, though, the problem involving planes in your homework is not too bad. Okay, so let's see an example. Example, find the equation for the plane through the point P naught, so they're calling it the point P naught, and this point is equal to 4, 1, 2, and normal to the vector. Okay, so and normal to the vector. Remember, normal means perpendicular, so a 90-degree angle. Okay, so normal to the vector, and here our vector is written, vector n equals 2i plus j plus 3k. Okay, so 2i plus j plus 3k. So actually all we have to do here is use this information I wrote up here. Okay, so they already gave us the normal vector. The normal vector is 2i plus j plus 3k. Okay, and then we have to plug everything in. Okay, so we know already that the plane is going to have the form ax plus by plus cz equals d, right? Where a, b, and c are the components of the normal vector n. So here we can see that our a, b, and c are just going to be 2, 1, and 3. Okay? So already we know that the equation of the plane is going to be of the form ax, so that's going to be 2x, plus by, so that's going to be 1y, plus 3z, so that's going to be, our cz is 3z. So 2x plus 1y plus 3z, and then the only thing we don't know is capital D. right? So we have to figure out capital D based on the information that they gave us. Okay, and of course 1y, you don't leave it that way, you get rid of the 1 and you just write y. Okay, so how do we find capital D? Well, fortunately they tell us that the plane passes through the point P naught equals 4, 1, 2. And keep in mind that that point has coordinates x, y, z. Okay, so what we can do is we can actually plug in x, y, and z into this equation that we have here, and then we can solve for d, and then we'll know what to plug in for d. Okay? So what we're trying to do right now is plug in and solve for d. Okay? Because we're going to need d to actually write the equation. So x is 4, y is 1, z is 2. So plugging everything in here, we've got 2 times 4 plus 1. So 2x is 2 times 4 plus y is plus 1 plus 3z is going to be plus 3 times 2. And this is all equal to d. Alright, so just using that point that they gave us and plugging in the coordinates, now we can simplify the left side. So we have 2 times 4 is 8, and 3 times 2 is 6. So we have 8 plus 1 is 9, plus 6 is 15. So we actually get d equals 15. Okay, but that's not our answer, that's just d. So what do we want to do? Well, our final answer is going to be 2x plus y plus 3z equals 15. So we're going to go ahead and replace d with 15 in this equation. Okay, so our final answer is 2x plus y plus 3z equals d, but we just solve for d and we see that that's 15. Okay, and that's the equation of that plane that they were asking for. Okay, so that's really not too bad, hopefully. Okay, so now in our next example, I actually want to combine what we've learned about lines in the previous lecture and planes in this lecture. So, new example. The instructions here are find parametric equations. Find parametric equations. For the line, through the point -8, 7, -9, perpendicular to the plane 2x plus 9y plus 3z equals 23. Okay, so find parametric equations for the line through -8, 7, -9, perpendicular to the plane 2x plus 9y plus 3z equals 23. So now at first you might be a little confused about how to do this, but if you think about it, to find parametric equations for the line, we really just need a vector that the line is parallel to, and then a point. Well, this right here is our point, so they gave us a point, so we can go ahead and label that as our x naught, y naught, and z naught. Okay? And we know that the parametric equation of a line, equations I should be saying, are given by x equals x naught plus tv1, y equals y naught plus tv2, okay, and then z equals z naught plus tv3. Right, and we already have our x naught, y naught, z naught. That's for the line passing through the point x naught, y naught, z naught. But now we need our vector v1, v2, v3. And that vector has to be parallel to the line. But they're asking for parametric equations for the line through this point perpendicular to the plane 2x plus 9y plus 3z equals 23. So can anyone think about what vector we would use? Well, if you were paying attention earlier, we talked about with planes you have a normal vector. Okay, so the normal vector n is just equal to ai plus bj plus ck, and we can actually use that normal vector as the vector we need for our line. So our plane has to be in the form ax plus by plus cz equals d, but we're going to be able to easily figure out our normal vector because it's going to have these same numbers here for the components. So a, b, and c are going to be the coefficients of x, y, and z here. All right, and that vector is going to be perpendicular to the plane. Okay, so the normal vector to our plane is given by n equals ai plus bj plus ck. Okay, ai plus bj plus ck, and so here our a, b, and c are given to us as the coefficients of x, y, and z. Okay, so a here is 2, b is 9, and c is 3. So the normal vector is going to be n equals ai, so that's going to be 2i plus bj, so that's going to be 9j, and then we have plus ck, so that's going to be plus 3k. Right, so that's our normal vector n. But the normal vector to the plane is actually going to be the same as the vector that we want for our line to be parallel to. Because if we use that vector, because it's perpendicular to the plane, the line also has to be perpendicular to the plane. Okay? Alright, so let me write that down. Since n is normal to the plane, normal means perpendicular, we use n for our line vector. Okay, so we use n for the vector for our line to pass through. Okay, so we want our line to be parallel to this. So remember, this is our vector n, but now it's actually going to be considered our vector v as well, since it's going to be our v1, v2, and v3 for our line. Okay, so v1 here is going to be 2, v2 is going to be 9, V2 is 9. And then V3 is actually 3. Okay, so using these parametric equations of a line and plugging everything in up here, we're going to have x equals x naught plus TV1. Okay, so x equals, well, what did we say x naught was? X naught was -8. So we have -8 plus TV1, well, that's going to be plus 2t. Okay, and then we have y equals y naught. So y naught we said was 7 up here. So we're going to have y equals 7 plus TV2. Well, our V2 is 9, so that's going to be plus 9t. All right, and then our third component is going to be z equals z naught, so that's -9, plus TV3. So that's going to be 3t, -9 plus 3t. All right, so that is actually going to be the equation of the line perpendicular to the plane. It's going to be perpendicular because it's parallel to the normal vector, and the normal vector is perpendicular to the plane as well. Okay, so that's going to be our answer. Okay. Okay, so now that we've had some fun with lines and planes, I wanted to talk about one last type of parameterization that you can do, which is parameterizing line segments. Okay? But I left it in this same video since line segments are technically part of a line. Okay. So we're just going to do this by example. It's going to be kind of similar to parameterizing a line. It just won't be exactly the same, because you think about a line goes forever in both directions, whereas a line segment has endpoints. It only goes from one point to another point, and it stops. It doesn't go forever in one direction or the other direction. Okay, so let's do an example here. Example. Find a parameterization for the line segment. Find a parameterization for the line segment okay, and this is going to be the line segment joining the points, the line segment joining the points points P, and point P is going to be 0, 3, 7, and point Q is going to be given by 0, -3, 7. Okay, so we want to find a parameterization for the line segment, so not an entire line, but just a segment, joining the points P 0, 3, 7 and Q 0, -3, 7. Okay, so the trick here is you actually want to find a parameterization for the entire line first, and then you're going to restrict the value of t, the parameter, so that it works for your little line segment. Okay, so our first thing we're going to do here is first find a parameterization. Okay, first find a parametrization for the line through point P, and it has to be parallel to vector V, and here vector V, we're going to find that by writing out PQ. Okay, and remember PQ is really the same as vector Q minus vector P, written as position vectors. Alright, so we're going to focus on the line first, and then at the end we'll turn it into a line segment by restricting the domain. So restricting the parameter T. Okay? So that's our strategy here. So let's start by, we already know what P is. That's 0, 3, 7. So we're good there. But we need to figure out our vector V, which is going to be written as PQ. Okay? And again, PQ is Q minus P. Writing them as vectors. So what's that going to look like here? Well, giving myself some room here, vector Q is going to be the components 0, negative 3, 7. Okay? And then we're subtracting vector P. So vector P is actually 0, 3, 7. So we do minus 0, 3, 7. Okay? And then after we do that subtraction, we'll have our vector. So remember, when you're subtracting, you can distribute the minus to each component of the vector. So we're actually going to switch all the signs in there, and we're going to have 0, negative 3, negative 7. And then we can add the components of these vectors. Okay, so just adding the components of the vector, we have 0 plus 0 is 0, negative 3 plus negative 3 is negative 6, and 7 plus negative 7 is 0. Okay, so our vector V, which is the same as PQ here, is 0, negative 6, 0. Okay, and what we're going to do now is we're going to write the standard parametrization of the line through point P parallel to this vector. Okay, so if we go way back up here, I wrote the formula again. Remember, the parametric equations of a line is x equals x naught plus tv1, y equals y naught plus tv2, z equals z naught plus tv3. So those are the ones we're going to be using here to parameterize our line. But keep in mind that for a line, t actually goes all the way from negative infinity to positive infinity. I wrote 8 for some reason. I guess 8 looks like a sideways infinity. Okay, so negative infinity to positive infinity. That's what makes it a line. Okay, so first we're going to go ahead and write down these parametric equations of the line. Okay, so we've got parametric equations of the line. This is not the line segment. This is the entire line. So it's going to be x equals x naught plus tv1 and so forth. So here, what's our x naught? Well, our x naught, y naught, z naught is just going to be point P. Okay, so here's our x naught, y naught, z naught. So for this problem, x naught is 0. Okay, so we've got 0 plus tv1. Well, here our v1 is 0, our v2 is negative 6, and our v3 is 0. Okay, so here we're actually going to have 0 plus 0t. 0 plus 0t. So that means x is actually just going to be 0. Okay, and then our y is y naught plus tv2. Well, our y naught here from point P is 3. Okay, so y naught is 3. So we're going to have 3 plus tv2. So that's going to be negative 6t. Negative 6t. Okay, and then we still need our z component. So our z component here is once again going to be z equals z naught. So our z naught here is 7 plus tv3. So our tv3 is going to be t times 0, which is 0t. And remember, any number times 0 is 0. So x is actually just going to equal 0. Y equals 3 minus 6t. And z is just going to be 7. So z equals 7. But these are the parametric equations of the line. This is not the line segment that they asked us to find. Okay? So because it's a line, we know that t is going from negative infinity to positive infinity. Actually, I probably should write it lower. Okay. So they usually write it right after the equations. So for this line, we know that t is going all the way from negative infinity to positive infinity. Okay, but we actually want a line segment. We want a line segment, not a line. We have to restrict t to an interval that gives us this line segment. So that gives us the line segment that we want. Okay, so what's that going to mean? Well, if we go back to the original problem, we wanted to find a parameterization for the line segment joining the points 0, 3, 7 and 0, negative 3, 7. So we want our point to start at 3 for y and to end at negative 3 for y. Okay, so how are we going to restrict t to an interval that gives us the line segment we want? Well, it turns out that we've actually done most of the work already. So for the line segment that we want to start at 0, 3, 7. Okay, so we start at 0, 3, 7. And then we need to end at point Q. So we need to end at 0, negative 3, 7. Okay, end at 0, negative 3, 7. So now the nice thing about the standard parameterization, which is what we used, is very often you're going to want t to start at 0 and end at 1. And you can just check to make sure that it works. Okay, but I believe it will work for this problem. So generally your start for a line segment is going to start at t equals 0. And why does that work? Well, just plug in t equals 0 into our parametric equations here. So if we plug in t equals 0, we get 0, 3, 7. And that's exactly where we wanted to start. And then you just verify at the end, generally you want to plug in t equals 1. And when you're doing these problems, because of the standard parameterization, it should work out the way we set it up, that t equals 1 should actually give us the endpoint. But we can just verify that really quickly. So if we plug in 1 here, we get 0, negative 3, 7. So it did work. Okay, and the nice thing about all this is, as far as I know, you're always going to be starting at t equals 0 and ending at t equals 1 if you parameterize your line the standard way like we did. So that's the whole line segment bit. But then how do you actually write your answer? Well, you use the same parametric equations as you had for the line. It's just t is going to start at 0 instead of negative infinity, and it's going to end at 1 instead of positive infinity. Okay? So we're going to write down the exact same parameterization. So we're going to say x equals 0, and then we said our y was 3 minus 6t. Y equals 3 minus 6t. And then for our z, we actually had 7. Okay, so z equals 7. And then because of the way the parameterization works, the beginning of your line segment is going to be at 0. So what we write is t is greater than or equal to 0 on the left. And then we want our line segment to end where t equals 1. So t has to be greater than or equal to 0 and less than or equal to 1. And that's actually going to be our answer. Okay, so this whole thing is our parameterization. Okay, so line segments actually aren't that bad to parameterize. So you basically just parameterize the line first, and then at the end you restrict the domain of t, your parameter, usually to just 0 and 1. Unless you parameterize it in a non-standard way, you're always going to start at 0 and you're going to end at 1. Now for your homework, there's one more thing they want you to do here, which is at the very end, they want you to sketch the line segment that we just parameterized. And they actually want you to draw an arrow in the direction of the parameterization. Remember, you start at t equals 0 and you end at t equals 1. So let me do that. So they want us to sketch the line segment. Sketch the line segment. And we want to indicate, so we're going to be indicating the direction of increasing t, indicating the direction of increasing t for the parameterization. And you're not actually going to have to draw it, of course. It'll be multiple choice, and you're just going to want to choose the correct graph. But it's still good to be able to draw it so that you can choose which one is correct. Now, probably the easiest way to do this is to not worry so much about the parameterization as just the original points that they gave us. And this is just going to be a sketch. It doesn't have to be perfect. You just need to get the rough idea down so that you have basically the right picture for your sketch. Okay? So here's our x-axis, our y-axis, and then the vertical axis is going to be our z-axis. Okay, and then we just want to plot the 2 points that they gave us that we started with. So our point P was x was 0, y was 3, and z was 7. So if I go down to y equals 3 and z equals 7 way up here, our first point is going to be right there. So that's our point P, which was 0, 3, 7. And then we also want to sketch point Q. And remember that point Q in this problem was 0, negative 3, 7. 0, negative 3, 7. Sorry, having drawing issues here. Drawing is hard. It's always been hard for me. Okay, so here's negative 3. So our other point's going to be right around here, and that's point Q, which is 0, negative 3, 7. And then they also want us to draw the whole parametrization. So remember, for our parametrization, at the beginning, when t equals 0, we're starting at the point 0, 3, 7. And then when t equals 1, we've moved our particle all the way to the endpoint, which is 0, negative 3, 7. So they want you to actually draw a line segment and draw an arrow from start to end. Okay, so you're going to be drawing an arrow going from your starting point to your ending point. Okay, so we need to draw our arrow starting at 0, 3, 7, and then it needs to be pointing towards the end, which is 0, negative 3, 7. Okay, so we're going to start here at point P, and we draw our line segment, and then we draw an arrow showing which direction the parametrization is going. So it's going towards Q. It starts at P and it ends at Q. Okay? And then if you want to write that in words, on some of the questions in your homework, they're going to ask you to write it in words. You can say T, the parameter T, parameter T is increasing from our start point to our end point. So from P, which is 0, 3, 7, to Q, which is 0, negative 3, 7. Okay? Cool.